first curator between 1974 and 1981. And one evening in May 2018, he gave a fascinating talk for us, A Curator Looks Back. Well, tonight, John is taking just one aspect of this talk, steaming up at the waterworks and the 1895 Lancashire Boiler, and bringing this to a wider audience. But before we ask John to make a start on his talk, there are just a few points of housekeeping, if you could bear with me. First of all, if you could please keep yourself on mute throughout the talk so that we avoid any noisy feedback, and we'll all hear John nice and clear. Secondly, John will attempt to answer any questions at the end of the talk. You can submit a question via the chat button, which should either be at the bottom or on the right-hand side of your screen. Kathy Burrows, who has organised tonight's event, will be monitoring questions as they come in and collate them at the end of the session. And then finally, please note that this talk, but not the Q&A, will be recorded, and we eventually will publish this on the museum's YouTube channel within the next week or so. And we'll send a link to this by email when it's available. Please feel free to pass this on to other people who you think might enjoy it. And so now, with that brief introduction, I'll ask Kathy to hand control of the screen across to John.
Yeah, so John, over to you.
Thank you very much, Kathy. I need to stop this share, don't I? Good evening, ladies and gentlemen. I apologise if during the course of the evening we appear to be looking at the wrong screen or the wrong face or indeed the wrong engine. That's entirely my fault, but this is the first time I've used this Zoom technology, and despite the enormous help which Kathy's given me in the last week or two, and indeed Richard, there are still significant gaps in my knowledge which may well show up as the evening proceeds. As Richard's already said, what I'm proposing to do is to talk quite specifically about part of the museum and the pumping station which I was familiar with mainly in the 1970s, which most people will not now be familiar, and that is to say the Lancashire Boiler. The reason being, of course, that the Lancashire Boiler is no longer in use, and so there will be a relatively few number of people that will remember, or even more will have experienced working on the boiler, in the boiler, under the boiler, or actually helping to maintain it. And I thought that by talking about that, it will put on record something which otherwise is going to gradually die. So what I'm going to talk about this evening, what I'm proposing to talk about, is first of all the situation as I found it in 1974 when the trust was set up. Secondly, very, very brief details of the history of the boiler and of the technology of it, how it actually works, but mainly what was involved in the maintenance and operation of it. So what I'm going to do now is we'll go back, if I can manage it, back to the original slide, which will take me a second or two. Please bear with me, and we'll go into where are we? Right, I hope you can all see on the screen the front of the boiler as we know it today.
Yep, that's showing nicely. Good,
thank you. So when the trust was first formed, or even before the trust was actually formed, when the initial group of people first met up at the museum, we determined straight away that the key thing we had to do was to get the two pumping engines working. They were obviously going to be the big attraction at the museum. In order to get the pumping engines working, we had to get the boiler working. And it's the boiler that you're looking at now. Now, I'm assuming for the purpose of this talk that although It's a talk given primarily to members of the Museum Trust. I do know that there are other guests watching. There are other guests who may indeed not have been to the museum at all, or may not be familiar with steam machinery and so on. So I shall keep the descriptions, I hope, at a fairly low level, if you don't mind me saying so. So in the hope that everybody will understand what we're talking about. So in 1974, we were faced with getting this boiler into working order, and it was at that time 79 years old, which is significantly old for a boiler. Locomotive boilers, generally speaking, don't last half that time. So it was an old boiler. It had been built in 1895 at a time when the triple expansion engine was put in. As far as I'm aware, we're still not absolutely sure who it was built by. It was either by a company called Wiley and Company or by a firm called Meldrum of Timberley in Manchester. The name Meldrum will come up later. The important thing was that in 1974, the boiler had been disused for 24 years, best part of a quarter of a century. It had been lying idle. It hadn't been touched. It had had no treatment at all. The building was not a very good state, so there was a lot of damp, a lot of water coming in the building, and it must have been questionable as to whether the boiler was fit for further use at all. Just 2 years later, less than 2 years later, had you stood in the same place, this is what you would have seen. In fact, this is August 1977, and this is a little short bit of film from BBC Midlands Today. So that was just a little short clip that was made for Midlands Today, as I said, and that's what you would have seen. You'll notice that Patrick Edwards, who was one of our younger members at the time, well, in fact, they were all young members pretty well, was firing the boiler on wood, and we'll talk about that later. And so within a period of less than 2 years, significantly less than 2 years, this completely derelict boiler had been put back into steam. Clearly, there's a great deal of work had been done in the interim, and it's mainly that and the general maintenance that I'm going to talk about this evening. Now, I'm hoping that most of you will be familiar with what we're actually looking at on the screen at the moment. That's to say, the face of the boiler, as you would see it if you went into the museum, wearing your mask and keeping the appropriate distance, of course. But if you went in today, this is more or less what you would see. But unless you were knowledgeable, you wouldn't know that behind that face and behind the wall that surrounded it was, in fact, a significant structure. And it's that I really want to explain and to show to you, because if you go to the museum, that is part that you cannot get to, you cannot see, except perhaps through the use of photographs. So I need to start off by saying, what is a Lancashire boiler? Essentially, a Lancashire boiler is a tube. It's a tube, in our case, about 7 feet in diameter and about 20 feet long. So that's quite a big piece of steel. It's called a Lancashire boiler because it was used very extensively in Lancashire, and it was a development of an earlier boiler, about 1840s, an earlier boiler called a Cornish boiler. The only difference being that the Cornish boiler had, instead of having these 2 fire tubes here, the Cornish boiler only had 1 in the centre. Obviously, by putting 2 fires in, you were significantly increasing the amount of heat that you could apply to the water. So immediately there were economies. There are other advantages as well. The tube, the 7-foot diameter tube, has riveted onto the end that we're looking at a flat plate, this huge disc of steel, and onto the other end a similar disc of steel. So the tube is closed up at both ends. And if we apply a pressure to the inside of that boiler, a significant pressure, then these two flat surfaces at each end are the weak points. Because they're flat, they're going to try and bow out in a sort of balloon shape. And in fact, if things go seriously wrong, that's what will happen, and we shall get an enormous explosion. And one of the advantages of putting two fire tubes through from this end to the other end is that you reinforce the two end plates. You help to provide a structure between the end plates which stops them being forced out. Also, we can see indications that within the tube itself, and we will have a look at these in a while, there are some pieces where indicated by these rows of rivets. The rows of rivets simply indicate gussets which are put in there. They're triangular pieces of steel which reinforce the end plate against the main tube. The biggest problem with these boilers, as with all boilers, but excessively in the case of Lancashire and Yorkshire and Cornish boilers, is that they are so huge, and therefore at most of the time during the lighting up period and the cooling period, there are tremendous unequal stresses within the structure. So if we fill this in practice up to about that line there, which is 2/3 full of water, cold water, and then we introduce two fires into here, or even one fire, we are immediately, as soon as that fire gets alight, introducing a lot of heat into these steel tubes here, whereas the far end of the boiler is probably still stone cold. So we begin to get a lot of very, very unequal expansion. Things start to move, and this is where we get problems with these boilers. Over the years, as various pieces of steel within the structures move unequally, both by heating and by cooling, then these rivets and round the outside and numbers of other rivets, which we shall see in later pictures, begin, if you're not careful, to leak. And this is where maintenance is required. The main shell of the boiler, that's the actual tube itself, is about 16.5 millimeters thick, to be precise, 21/32. It's not really that thick. And the actual fire tubes here are only about 1/2 inch thick, the steel. It always surprises me how thin these boilers actually are, considering the enormous forces inside. Now you're perhaps wondering, well, what forces are there inside? The boiler was constructed to work at a pressure of, using old money, 160 pounds per square inch. That was its normal working pressure during its main operating period. In order to do that, it had to be tested when it was first put in, and it was tested at 300 pounds per square inch. That's to say, about the size of each of these rivets had something like 300 pounds of pressure inside the boiler pushing out. So you'll realize that although it's a relatively thin structure, it's enormously strong. When I was working at the museum and we were in steam and people used to come through, and we were talking perhaps about the sort of pressures that were involved, to put it into layman's terms, I used to get a piece of chalk and mark onto the face a little square, roughly 5 inches by 5 inches. That's sort of roughly, I hope you can see my cursor moving around, a little square like that, 5 by 5. And I used to say to people, Well, in very rough figures, for every 5-inch square on the boiler, on the face and on the tube at the back that we can't see, there is roughly a ton of force pressing to get out. Now, I know that's not the correct physical way of putting it, but people understood that. 1 ton is pressing on every 5 square inches, and that was approximately the sort of force that has to be held within this boiler. Clearly, it's a quite dangerous piece of equipment, potentially, if it's not looked after. The other bit of information which people used to ask, and we will come on to, I'm sorry, I'm holding you on this this picture for rather a long time. In fact, we can go on to the next one. The other thing they used to ask was about the sort of temperatures involved, as well as the enormous pressure that was inside it. The flame temperature of the fire could be anything up to about, at an excess, 1500 degrees centigrade. And if you think that steel actually melts at a lower temperature than that, so we are creating a temperature within this boiler which is hot enough to melt the steel itself, potentially. Clearly, there is a danger sign should be registering there. And we had water, which, when it's being turned into steam and used at its normal working pressure, would be at something like 190 degrees centigrade. So we have hugely hot water. So we have the combination of intense heat in the fire, scalding water in the boiler, and enormous pressures. We have 3 factors which should all ring a few alarm bells. And we'll talk about that, the alarm bells, a bit later on. So now let's look at the actual construction, and we'll get through to looking at a few more pictures, and we'll move on somewhat. As I explained, we have the outer shell, we have the 2 fire tubes, which obviously contain the tubes and the fire, and we have a water roughly up to that sort of level. We have 2 areas which have to be maintained, 2 entirely separate systems. We have the system within the tube itself, which is basically water and steam, and that tends to generate scale, which over a period of time will coat the inside of all the steelwork. Scale will build up the outside of the shell and around the outside of the fire tubes, and the worst of it will fall to the bottom and form a thick layer on the bottom of the shell and across the tops of the fire tubes. So that's one system that we have to maintain and look after. The other system is the fire. The fire is going through these 2 tubes. When it reaches the other end of the boiler, it comes out the tubes at the other end, and it goes to the left and to the right, and it comes back through this tunnel or flue. The reason for that is quite simply that obviously by the time the fire, the combustion, the smoke, the gases and so on reach the other end of the boiler 20 feet away, they are still intensely hot. And so in order to maximize the use of that heat, it is returned down the outside of the boiler through this flue and heats the water that is in contact with this surface here. The heat from that fire tube, the right-hand fire tube, comes down the right-hand flue. There's a dividing wall right down the middle at the far end of the boiler. So the gases are now coming towards us. When they reach this end of the boiler, that's to say almost at the point that you can see in the museum today, they then dive down, they join together, and they go back underneath the boiler to the far end. So the whole of the outer surface right round the outside of the shell here is being heated, as well as the inner surface where the fire tubes are. we're maximising the fire that's in there. What we have to do, because as I've pointed out, the fire can be hotter than the melting point of steel. So we have to make sure that the steel is always covered by water. So if, for example, within this fire tube here, we have a fire, and if under pretty well unforeseen circumstances, it reached the maximum temperature of 1500 degrees, it would, in the normal way of things, start to melt this steel, or at least it would heat it up to a very red hot, and it would start to go soft. But it can't do that if there's water on the outside of it, because the water itself can only reach a maximum temperature before it turns into steam. Depending on the pressure, it will normally get up to about 180 degrees or so, the temperature of the water. Because the water reaches 180 degrees, the steel itself can't exceed that temperature, or only marginally, as long as there's water there. So the water is one of the safety factors. The water prevents the steel melting as long as it's there. If the water gets low, if this level drops and drops and drops down to, let us say, here, then the top of the tube is exposed. The top of the tube can then begin to heat up rapidly from the fire inside to become soft at the top, and the pressure of 160 pounds, whatever it happens to be inside, will then push this tube in, and we shall be in a potentially explosive position. As long as there's water there, then the steel is safe. However, if the steel itself gets covered with calcium, with hardness from the water, let's say on the top here, there's a thick layer of a build-up, let's say of 1 inch of scale on the top. That scale is an insulant. It prevents or reduces the transfer of heat from one side of the steel to the other side. It's an insulating layer. Because it's an insulating layer, the water, the cooling effect of the water, is lessened considerably. And if there is calcium and scale on the top here, it is possible for the steel to overheat, even if there's water above it, if it's insulated by the calcium here. So we have two dangers we have to think about all the time. First of all, keeping the scale off the steel, and secondly, keeping the level of the water high. Let's move on to looking at a little bit more of this gas flow. This is not actually the Broomy Hill boiler, but it's a very similar one. And this end here is the end that we're normally looking at when you're in the museum building. You'll see we've got the two fire tubes here. The fire goes right the way through to the far end, and at the far end it then goes left and right, that's to say towards us, and comes down the right hand side tube flue and the left hand flue, and then it joins together and goes back up the bottom. It continues along and eventually will go up the chimney stack. We'll talk about that a little bit later. That is the general shape of the boiler. It's a very simple thing. This long tube, flat plate on that end and on that end, and the flues at the side to carry the products of the combustion. Here is the fire. The fire is laid on some cast iron fire bars, simply supported within these fire tubes, and with a brick wall across the end. The brick wall across the end is to stop the over-exuberant fireman chucking in the coal too hard and gradually filling up the bottom of this tube with coal. So the coal is supposed to be confined to this area here, below it will be ash once the coal has been burnt, which can be raked backwards. So that's the general shape of the boiler. So we've got these two different areas within there. We've got the water area and we've got the flue area. And to keep the, we'll look first of all at the water area. That's accessed in two ways. To get at the inside of the boiler, there are only two ways of getting in. One is through a little door here, a mud door, which we'll see in a photograph in a moment or two. And the second is in through a manhole cover, which is on the top. In the case of the Broomy engine, it's in the middle. And you can climb in, and that will get you into the water space. To get into the flue space, you have to go in underneath here. And again, we'll come to that in a moment. I want to deal more, first of all, with the water space. And the water space has to be cleared out annually to remove the build-up of scale. So if I've got it right, the next little piece will be a little bit of video from the Blue Peter film, which was made in 1978. And you'll see John Noakes and myself, we're going into that manhole at the top. And within the boiler is one of the lads who I was teaching at school, who came in and helped on the now and again. And he's sitting on top of this fire tube here, chipping and wire brushing. So that, I hope, is what we shall see. Sorry, it isn't what we shall see. This is just a view looking in from the underneath. This is the water space at the bottom, where we get a lot of scale building up. And these are the two fire tubes. You'll see there's no room to get between the fire tubes down into the bottom here. Let's see, here we are.
Top of the boiler, John. Here's the pipes which carry the steam through to the engine. And here's where you're working, down inside the boiler. I think Jeremy's already in there. Are you in there, Jeremy? Yes. Yes. All right. I better come and join you. I smell those spaces. I've been working on this for the past week or so. Yeah. Why are you actually taking on this cost of the well, if you wasn't taking on the boiler, we were over the heat and that might be nasty. Oh, I see. It could explode. And you do all this volunteers? Yes. Volunteers. Here we go. Can you give me a hand for it, please? Yeah. I don't regret leaving you here.
You'll realise that the Blue Peter team had to make a bit of a story out of this.
I'm afraid that we don't have the luxury of tea and trying to go outside the Kew Bridge, but perhaps you can pass those to Stephen. He's down in there. Oh, Stephen! Cup of tea?
This is the mud hole that gives access to the bottom of the boiler shell. Okay, so I've put that in because it just gives a general introduction to the shape of and the appearance of the inside of the boiler. So we've got the two areas, the area above the fire, which can be cleaned by chipping with a chisel and a hammer or by a wire brush, and the area below, which is accessed through this manhole, mud hole here. Now you'll realise, if you look at the size of it, you'll realise it's not everybody that can get in through that hole there. And having gone inside, there's not really room to turn round underneath the two fire tubes. It's very restricted under there. The biggest problem was cleaning up the corners up here. That narrow gap between the fire tube and the outside shell inside here was very difficult to access. So to service the actual flues, which are the other part of the system, the only way you could get into them was by lifting this inspection cover off the floor here and then climbing in through a rectangular door into the left-hand flue here or the right-hand flue here, although they both join together underneath. But that's the only access, or was the only access, of getting into the flue area. Having got into there, so we're now we've come into the bottom here. We're now going to I'm just checking on which of the picture that's coming up. Yes, having got underneath there, we then have the choice of either crawling down this flue on the right or this flue on the left, which is what we're going to do now. And here is the right-hand flue. You'll see, well, you'll get an idea that it's not actually very wide. It's probably little more than shoulder width across here. In this particular shot, it's full of, there's a lot of rubble in here because this was at the stage when we were renovating the boiler, and a lot of the brickwork which was supporting it and the brickwork at the edge of the flues had to be chipped out so that the boiler inspector could examine all the seams of the boiler. Just here, there's an overlap in the steel sheets that make the boiler up. And where there is an overlap, which is riveted, the boiler inspector has to be able to see that to check that there are no leaks. In order that he can see it all the way round, the brickwork has to be chipped out and smashed away. So this flue obviously would not normally have all this rubble in it. I think also we've got some temporary shoring here to hold up some new concrete work which was going on up above. So if we crawl down this flue to the far end, we're actually going in the reverse direction to the actual flue gas. The flue gas normally would be coming towards us, so we're going in the reverse direction. We'll crawl down to the far end, and when we get to the far end, we come out round a corner, and this flat floor here, you'll see perhaps in the next shot where we are, we're actually at the far end of the boiler where the two fire tubes come out. One of the fire tubes lets the contents of one of the fire tubes rather goes down this side entrance here. This is the left-hand flue going back down, all the way back down 20 feet. So we've actually crawled up a side flue and we've come out of there, and we're now at the back of the boiler. In fact, we're here. That's where we are. We're right at the back of the boiler in that area there. And here we are, we're looking down on the top. There's the two fire tubes coming out of the boiler. There's a side flue here. It's actually the right-hand side flue, looking at it as you would see it in the museum. The left-hand flue is here, and there's various bits of, some of this walling is only temporary because we had to knock a lot of this out for inspection purposes and then rebuild it. So walls had to be built temporarily to hold up shuttering for putting new concrete floors and so on in here. But it did give the opportunity to see the back end of the boiler. If we went then into the fire tube itself and crawl back towards the fire, this is what we'll see, and we call this picture is Spot the Curator. The curator is here, so I've crawled back through the fire tube and I've now reached the brick wall across where the fire is. So normally the fire would be in the front here. The brick wall is to stop the ash and wood and so on being thrown all the way down the tube, and I've crawled up the back. You have to do this because obviously from this point onwards, from that wall onwards, there is going to be soot and ash, which has to be removed. And that's what I'm doing in there. This tube here, we'll talk about in a minute or two. That's for sucking out the soot. The access to here, I have to say, was frighteningly difficult. I don't know if I can go back to the previous one. Yeah, here we are. So I'm now in here. I'm in that area behind the wall. Behind me are 3 tubes. 2, 3. There are these 3 tubes here called Galloway Tubes. And they stretch right the way through the fire tube, as you can see here. They're full of water, or would be full of water when the boiler was being used. The idea is that because they get intensely hot, they've got the full heat of the fire, water inside them rapidly turns nearly to steam, and it simply promotes the circulation of the water. It encourages the water to move around within the boiler so that the temperature of the boiler throughout maintains a more or less even temperature, if possible. The big problem, of course, from the point of view of anybody doing maintenance, is that you have to access from the back and then get between these 3 Galloway tubes. And you can see, however you look at this picture, the tube is 2'6", I should think, diameter. There is not much room. And I will say that probably after, in years after I worked there, that I did get a certain amount of terrors thinking about what would have happened had I become unconscious or ill or whatever within that place there. It's very difficult to imagine how you could actually be got out. And certainly if at the point where you were going between these tubes here, one can't imagine how you could be removed from there. But however, that didn't happen, so all was well. We'll carry on. Here we are now back in the water space, and there in fact is the Galloway tubes going down through the fire tubes. So as I say, they get extremely hot and they cause the water to circulate. Having reached that wall at the end of the fire, the only way out was the reverse of what I have just described. You had to go to the back of the fire tube, to the point where it came out the back of the boiler, round through the side tube, and then round to the front of the boiler. So it was a lot of crawling involved at every stage of this particular game. Having crawled and reached here, we're now in a position to go into the bottom flue, which we haven't yet got to. So we've come down the side flue, we're at the bottom here, and we're now going to go up through the bottom flue until we reach the far end. Now, at the far end, if you look carefully, you can see the 2 fire tubes here. And at the far end, all the gases eventually, having come through the bottom flue here, join together, and they come out towards the photographer, towards us. They go left along a tunnel and up the chimney. Before they do that, there is here a sort of guillotine-like arrangement, a frame which has a steel shutter in it, which can be raised and lowered against a counterweight, and that is to regulate the flow of air through the whole system. By raising and lowering that shutter, you could control how much air, how hot the fire was, and so on. This flue going to the left here, which I haven't got a photograph of, but we may need to talk about that a little bit later. So now, as to actually clearing the flues, and getting the soot out. The best film we've got of this is again from the Blue Peter visit with John Noakes in 1978. Although I will point out that the soot had already been removed by the time the filming started.
We're looking for Tom. Now, you've got to go in through that hole, turn left, follow your nose, and you'll find him. And here's his teeth. Yeah, we're going to see if I get down there. They're going to come all the way back. Tom?
So this is the bottom flue.
The squeeze through was only 38 centimetres square. A couple of bits and places. Nothing quite like this. Right, cup of tea. Hi, John. What actually happens down this part of the boiler?
Well, the smoke from the furnaces comes down through here, up the chimney.
Oh, that's why it's so sooty.
Yeah.
It's filthy, isn't it?
Yeah.
Well, enjoy your cup of tea, aren't you? I'll say goodbye. Hang on a moment, John, before you come out. You see that flue up on your right-hand side? Well, I've got a job for you up there. A bit of cleaning to do. Can you take this? Yeah. It's a vacuum cleaner.
So he's now going to go up the left, that slope on the left, and up into the right-hand side flue. And I will say this is staged.
You're crawling down the side flue of the boiler. The flame and the smoke pass down this, and at the time they do, they warm the water that's above your head in the boiler itself. There's about 11.5 tons of water in there altogether. Oh, this one. That's right, above your head. Really, what you're going to be is a cross between a Mrs. Mop and a chimney sweep, isn't it? Oh, that's about it. Right, I hope it sucks instead of blowing.
Now, as I said, the visit of Blue Peter, whilst it did us an enormous amount of good, terrific amount of good, was of course entirely staged. There was no soot in there at all. The boiler had already been cleared out, and most of the chipping had already been done. So the actual procedure of removing the soot, which was usually up to about 2 inches deep, some places it would have been more than that, was done using this, what would it be, about a 3-inch hose, which we call Monty the Python for obvious reasons. Now, Monty the Python had a scraper built into this end. Actually, it was a nozzle in the shape of a scraper, so you could push that scraper along the floor or up the sides and suck in the soot. The vacuum was created using a homemade ejector. And sorry, I'm going to go back for a second or two. I've lost myself there. I'll talk about the homemade ejector in a moment, but basically we're sucking out wherever you are within the flue system. We're sucking out the soot and taking it outside of the boiler. Now, John Noakes rather made light of the whole of the flue cleaning business. He joked using his little vacuum cleaner and so on and so forth. The actual circumstances of doing it were not at all pleasant and certainly not as jolly as he made them out to be. So the next little bit is some 8mm film, which I'm afraid is not very good, but it's rather poor quality being 8mm. But at the end of the sequence, it is only a short sequence, you will see the volume of soot that is not only on the floor, but on the outer shell of the boiler and on the brickwork. And this will give you some idea of the sort of circumstances that were under there. And I must say, although in the beginning of this piece of film, I think you'll see me wearing a helmet. We didn't normally wear a helmet in there. It was just too unwieldy. You were crawling along, the thing was falling off all the time. And of course it gave you extra height, which meant you were constantly banging the helmet on the brickwork. So we're going to the 8mm film, which I think I can talk about. There is, of course, no sound to this. We did try an experiment using a light fitted on a helmet, but it actually wasn't. It was too directional, and in the end, we used to take a mains 240-volt light down there. Of course, it did mean at the furthest extremity, you've got about 40 feet of Monty the Python to drag behind you, because you had to drag it right down the side flues and then up the fire tubes. So I'm brushing off the outer shell, and when the light changes in a minute or two, you will see the sheets of soot begin to fall. They're coming down. You can see them coming off the shell of the boiler above us. You see. Now watch this lot coming down here. That's on the steel shell of the boiler. Meanwhile, outside the building is the outer end of Monty the Python. Now I think I'm going to stop the picture here, possibly. Yeah, just to explain what's going on. Monty the Python is coming out from the left-hand side from the boiler house. It's going into this container, and there's an ejector, which is just basically a nozzle through which air is being squirted from the main compressor, which we had installed at the time, and it's causing a vacuum in the same way that normally an ejector or an injector on a locomotive will cause a vacuum. This was causing an air vacuum, so it was drawing the soot out. We didn't know quite what to do with the soot. There was such a volume of soot coming out of this hose, and so we decided that the best thing to do was to take it down into a container of water in the hope that this would damp it down and prevent it flying around. It wasn't successful because the volume of air, the pressure of the air was so great it simply bubbled up all over the place. And so in the end, as you'll see, I hope in a minute, we had to resort to just blowing it to atmosphere, basically. Whoops, let's go back again. Sorry. Not quite sure if I think I've lost this bit. Yeah. So I'm going to have to run through this little bit of film very quickly again. I can't short circuit it, but I just want to show you what happens when we get to the end of the sequence of blowing the soot out. Now, I'm not sure if this system continued to be used in the latter years. Maybe there is somebody watching this presentation tonight who can explain to us whether they carried on using Monty the Python or whether they developed some other system for getting the soot out. I'm afraid I don't have that knowledge. As I said, generally speaking, when you first went into here, there would be 2 inches plus of soot on the floor. And then, as you can see, the what would there be? I suppose about 3/8, half an inch of soot on the shell and on the walls. And of course, it would get worse the nearer you got to the actual fire. As you worked your way down through the Galloway tubes and to the back of the furnace, the soot and the ash and so on would be worse, but there'd also be lumps of coal and wood. So what you'll see in a moment is a separate shot when we've abandoned the water dampening system because it didn't work. So at the front here is the small bore pipe from the compressor feeding through a nozzle, and the big pipe, Monty the Python, coming in from the right hand side, and the big pipe on the top of the system is to take it out into the water. And you can see what happens. It just blows it about all over the place. Wasn't very successful at all. So that was abandoned, and it was a long pipe was put in, but not long enough, because we found that we were getting covered with soot, so we had to put an even longer one in. And eventually, I'm not quite sure what health and safety today would have said about this. I suspect it wouldn't have gone down too well with anybody involved with controlling the environment, but at the time it was the best we could do, and that was how we got rid of it. The other bit of maintenance that had to be done very briefly on the boiler was that when it was inspected, or when a boiler test was carried out, as well as breaking through the brickwork where all the joints were, we had to remove all the lagging off the top of the boiler. The top of the boiler doesn't have a flue over it. It is simply covered with a thick layer of about, as I say, about 5 inches of lagging. That had to be removed, and then of course it all had to be put back on again, and it had to be put back on when the boiler was warm. So this is a man now called Bernard Mitchell, who's plastering the boiler prior to the very first steaming, and this was done in the middle of the night. We spent about 3 days warming the boiler up, during which he got I think two coats of plasterwork on top of it. And here we are on the very first day of lighting the boiler, and we're using timber. As you saw with the Midlands Today film at the very beginning of this presentation, we used firewood, and we used that for a number of years, mainly because of the cost of the alternative of coal. We had an access to free timber, and to keep the costs down, because so much money was being spent on the rest of the museum, we fired entirely on timber. Not wholly successfully. First of all, it didn't give the heat. You couldn't maintain the pressure very easily, but more importantly, you needed to fire absolutely continuously. You were pushing in wood almost without a break. The fire itself had to be built right up to the top. You had to push lumps of wood in right along the top of here to keep up sufficient heat. And over the period of a steaming weekend, we would use about 4 or 5 tons of coal, to give you some idea. If we look outside the building here, here's a pile of timber. That's part of it. Part of it is behind where I was taking the photograph from. There was another huge pile there. 4 or 5 tons of timber is actually a substantial amount in terms of volume, and we had to barried across during the course of the weekend. For those of you that are in the trust, in the museum, work in the museum, the next little bit of film, not particularly good, but it's a blast from the past. It's Jim Lafford firing on timber. So that's Clive's father. Jim obviously was the real mainstay of the museum in the early years. He was the only one that had water engineering experience. He didn't have a lot of experience of the boiler. He had, I think, fired the boiler once or twice, but he wasn't. I don't think he would admit that he was completely a steam man as such, but he did a lot of the hard graft and spent many hours here firing the boiler up for us. But then eventually we went over to coal, and so here's Martin Burgess, who most of you will know, I suspect, doing some firing on coal. That was a different kettle of fish altogether. And then again, for those of you who may remember him, a little bit of film of Bob Benson, who was a trustee, also firing on coal. And you can see here how we only need a much lower fire. You only need about half the thickness that you need with wood. It was traditional, it was normal to fire the tubes alternatively. So you would fire one, leave it for a bit, and then fire the other. The big problem here is that because the fire is 5 or 6 feet long, it tends to creep backwards because the air is coming from the front. The fire is working its way backwards towards the wall at the back. So you have to keep dragging the fire forward, which is what Bob's doing. He's bringing it forward. He'll then put fresh coal on top of it to help it ignite. And as it ignites, that will then take the heat backwards. And then a closing shot of the boiler, working on coal, as I like to remember it, between April 1976 and about 1994. Richard has been looking up some records today. We think the boiler was last used in 1994, which was after the time when I was working there. I think back to those days, and whilst there's of course nothing that could be done about the circumstances of the time, it did give a completely different atmosphere to the boiler, to the museum. The boiler formed, if you like, the heart of the museum. People tended to gravitate there and to stand around in the heat. Now you might think that in the summer, of course, it was absolutely unbearably hot in there. But even so, after people had watched the pumping engines were working, they seemed to gravitate back to the boiler house. It became a focal point. People liked to be involved in not only in talking to the firemen, whoever that might be, but also, of course, in actually helping to fire. We encouraged people, particularly children, to put coal on the fire and to give it a bit of a poke now and again, probably in ways which wouldn't be permitted today. In fact, I dare say you wouldn't even be allowed in the boiler house because, for goodness sake, the face of that boiler is very hot. And whilst we trusted people not to touch it, I don't think you're allowed to do that today. So I think it's very unlikely that even if the boiler physically had been able to be kept going, that it would have been practical in today's circumstances. I do, however, recommend that all of you do try and go to a place where there is a Lancashire or a Cornish boiler working. It is something all-encompassing to be in the heat of the boiler house when it's working. There are a number of pumping stations around which are still using coal-fired boilers, and I really do recommend it whilst you can still do it, because I think it can't be long before the dead hand of health and safety stops them being used, or indeed the increasing prohibition on the use of coal may actually make life very, very difficult. So with that concluding reminder of what the boiler looked like when it was in steam, the Lancashire boiler, I'll conclude the presentation, and I'm happy to answer any questions you may have that you perhaps have already put on the chat system, and maybe we can make one or two other comments as they arise. Thank you.
Thank you very much, John. That's really interesting. We've got one question. It's about the economizer. What part did that play in the boiler's efficiency?
As I explained, or as I hope I explained, when the flue gases got to the back of the boiler, they then effectively turned right and headed towards the bottom of the chimney. They went through a brick structure, a flue, which was some 20-25 feet long, and within that flue, which is now removed, it doesn't exist any longer, there was a thing called an economizer. And the economizer was simply, and it is quite a simple thing, it was simply a number of vertical cast iron tubes, all joined together, containing the water which was destined to be put into the boiler. So all these tubes were linked at both ends, and they were hanging down within the flue, the boiler flue, between the boiler and the chimney. The idea being that there was still a fair amount of heat left in the flue gas. It would heat the water that was in the cast iron tubes, and that water would then go into the boiler. So in effect, you were putting hot water into the boiler instead of cold, which obviously was reducing the amount of coal that had to be used. Now, to give you some idea, I did look this up earlier today. The water, this was a test done when the economizer was first put in, which we think was put in at the same time as the Lancashire boiler and the triple expansion engine. So it's 1895, we think it was put in there. And Greens, the firm that built it, did some tests, and they found that feed water going into the economizer at 32 degrees was coming out at 121 degrees. So there was a significant increase in the temperature of the water, and effectively using up the heat in the flue gas, which would otherwise simply go up the chimney. I've got a picture of an economizer. Oh, I should say that these vertical tubes, because they were hanging in the flue, very soon became covered with soot. The fact that they were covered with soot would have meant that the water inside wouldn't have got so hot. And so around the tubes was a piece of plate, a horizontal piece of plate with holes roughly the same size as the tubes. And the plate rose up and down. And as it rose up and down, it scraped the outside of the tubes. It scraped the soot off. Now, what made it rise up and down was the plate was fixed to some chains. The chains went over a wheel, and in some boiler houses, there was a little steam engine on top, which chunted away all day long, moving the plates up and down and scraping the soot off. In the case of Broomy Hill, we think that the economizer, the plates moving up and down, was actually worked off the end of the crankshaft of the triple expansion engine. Where the triple expansion engine has a crankshaft projecting on the south wall and a little feed pump fitted on the wall, we think it probably went through that wall and drove the economizer.
Okay, thank you very much. Got a question here. Why was the boiler put out of service?
You would have to ask somebody who was at the museum in 1994. I would suspect.
I could probably help there a little bit, John.
Yes, please do.
There were two factors. It was in the early 1990s when the sort of safety people started taking more interest, and it was the very early days of sort of confined space, regulated workings, and the adoption of regular inspections. And I can certainly say that I've taken a great deal from John's presentation tonight. So on behalf of all our members, John, thank you for a most fascinating talk and for the tremendous effort that you've obviously put in to pull this all together. It really is appreciated, your support in this way. Thanks also go to Kathy and Kevin Burrows for arranging and ensuring the smooth running of this event. Thankfully, the technology worked reasonably well this evening, so the backup plans didn't need to be used, which is always great. We haven't determined a topic for our next Zoom talk, but our plan is to hold 3, at most 4 of these next year. So the next event is likely to be in sort of February or March time. So finally, with just 10 days to go to Christmas, I'd like to wish all participants in tonight's event a peaceful and relaxing festive season, which comes with a sincere hope that by Easter next year, we'll be able to welcome you back to the museum in person. Thank you very much for attending and enjoy the rest of your evening.
Thank you, everybody. Thank you, Richard.